Okay, so if you are again not able to see the recording also, just drop me a mail. I try to just upload the video and again share you the link. Okay, so I think there is some problem with Microsoft Team. I again included IT team also, but it will persist for some time. If the lecture is not uploaded, just tell me, anybody. Okay. So again, if you remember the transition function of NFA, this is a set of states into an input alphabet goes towards the power set of states. Okay, so any NFA can be converted into a DFA, and any NFA, if you remember, any NFA can be converted to a simple NFA, and a simple NFA can always be converted to epsilon. So you just have to introduce a epsilon in this, because the meaning of epsilon is absolutely nothing. It means that from Q0 you can reach to Q1 without getting any input here. So you can freely move this. So absolutely, there is no particular kind of application of epsilon NFA. We do not want epsilon NFA to be there, because there are very less advantage of epsilon NFA. If you see, if I just remember that in the introduction of NFA, I told you that there is some advantage of epsilon NFA in the context of union. Okay, so whenever you want to combine two different NFAs, then epsilon NFA is very easy to use. Okay, so suppose this is a NFA in which number of A's are, I think number of A's are even. Okay, so if I just make like this. Okay, so in the same way, there is another, and there the number of B's here are even. Okay, so what do I do if I want to combine these? This is an NFA, this is a NFA1, this is an NFA2. If I just want to combine these, I just take a starting state Q0 and I just introduce the epsilon mode. So again, now this will be your NFA that is accepting your even number of A's or even number of B's here. Okay, so this is again the only, I think the only advantage of epsilon NFA is the implementation of the union operator. So you can combine any two different NFAs by using this epsilon move. Okay, so it just means that you can introduce any epsilon move here. Yeah, just Q0 from Q0. If you want to accept AA, you have to follow this path. Okay, so from Q0, if you want to accept BB, you have to follow this. Okay, so keep that in mind if you remember the definition and the part we have done about NFA. Okay, so again, if you remember that DFA and NFA, every DFA is absolutely NFA, and every NFA can be converted into a DFA, if you remember this. So I just say that these are both equivalent in power. Okay, so nobody, this DFA is not powerful than NFA, or this NFA is not powerful than DFA, because they accept the same set of languages. Okay, in the same way, this NFA can also be converted into a epsilon NFA by adding epsilon move here, and this epsilon NFA can also be converted into a NFA. I told you, I will tell you the procedure just in the coming slides. Okay, so again, NFA and epsilon NFA are again equivalent in power. So there is this epsilon NFA add nothing. So this DFA is equal to NFA is equal to epsilon NFA. It means that these three acceptors accept one particular language that is called your regular language. So don't just uh, don't confuse that what is a regular language. Okay, so I will tell you what is a regular language. There is a definition also, but by introducing a epsilon in the language, the expressive power of epsilon NFA is not increased. Okay, so if DFA is accepting regular language, NFA will also accept the regular language. In the same way, epsilon NFA will also accept the regular language. Okay, so by introducing a notation called epsilon, the expressive power of the automata is not increased. Keep that in mind. That is why I'm saying the DFA and NFA and epsilon NFA is absolutely equivalent to each other. Nobody is greater in power than ether. They are absolutely equal. Okay. Now again, the definition of this epsilon NFA is the same. You remember set of states, input alphabet, transition symbol, start state, and final state. Okay, so there is only a bit of a difference in the transition symbol here. The transition symbol for epsilon NFA here is a Q into input union. There is something called epsilon. Okay, so Q into input symbol union epsilon goes to a power set of Q. It is same as NFA, only this notation is increased. Okay, so if I just want to tell you that there is some kind of just take a example here that there is some kind of NFA exists, and then in that NFA there are two set of states. Okay, so the input alphabet here is A, B, and the union of epsilon is included in this. So it means that the Q0, Q1, there can also be a possibility if I do a union of these two, I can get A, B, and epsilon. Okay. So there is some one string introduced in the input here, that is your epsilon. It means that Q naught on getting a input of epsilon can go to any other state. Q naught on getting an input of A can go to another state. Q naught on getting an input of B can also go to another state. So keep that in mind that we have only introduced one thing, that is your epsilon in the already existing definition of NFA. So that is the only advantage of including epsilon here. You can see this input alphabet E. The definition of input alphabet E here is epsilon union input alphabet sigma union epsilon. Okay. So just if you just to revise that the transition symbol of DFA, if you remember, it is Q into sigma goes to Q. The transition symbol of NFA, if you remember, Q into sigma goes to power set of Q. And now the transition symbol of NFA is a bit changed. Okay, so Q into sigma union epsilon goes to power set of Q. Okay, so that is one and the same thing. In the same way that it just says that epsilon NFAs add a convenient feature. Okay, so they absolutely bring us nothing new. They do not extend the class of language. It just accept the NFA again, accept the same set of language that is accepted by your NFA and your DFA, and that is your regular language. Okay, so regular language that I have introduced a notation of regular expression. So regular expression is kind of representing the regular language in an expression. So don't worry about that. We will do that in detail. So I just want to tell you that the particular class of languages that are accepted by NFA, Epsilon, NFA, and DFA is called something a regular language. Okay, so if you do not understand it, don't worry. We will do this regular language in detail. Okay, so both NFA and Epsilon NFA recognize exactly the same languages. If you just stress upon this point, this is again saying the same thing, that both the expressive power of NFA is equal to the Epsilon NFA. Okay, so state to you can, it is just saying that you can allow state to state transition by using a epsilon here. Okay, so only the good feature of this epsilon is, if you remember, is union. Okay, so you can union two different NFAs and just write epsilon here. So that is a good property of epsilon that we can use. Okay, so again, if you remember something, that NFA and DFA. Okay, so there is a something called epsilon NFA, and this NFA can be converted to epsilon NFA by adding epsilon move here. Again, this can be converted to this. So if you want, if I given you a question that this convert this epsilon NFA to DFA. Okay, so you can go like this. First you convert it to NFA and then convert that NFA to DFA. Okay, so if you remember that step, the algorithm that we follow from NFA to DFA. So it can also happen. Okay, so this is a simple example of epsilon NFA. In this you will see that these are two epsilon moves here. Okay, so there is one new thing in this, that there will be a epsilon portion in the transition table. Okay, so it is saying that on A, getting an input of 0, it is going towards E, and getting an input of 1 on A, it is going towards B, and epsilon is not inputted in that, so that is why it is a dead configuration. Okay. So if you see B on getting epsilon is going towards dead D here, so B on getting epsilon is going towards D here, so that is written here. Okay, so one important step of this is something called epsilon closure. Okay, so if you have studied, I think in DBMS also you have studied this closure property. So it is a bit different from that, but the foundation concept is the same. Okay, so in that closure, if you remember that in normalization that these kind of things are written like A equal to B, B equal to A. So A closure it A itself, and from A you can reach towards the set of keys. So from A you can reach to B, and from B you can reach to A. So that is the closure of A. Okay, so that is the same foundation concept of this also. Okay, so epsilon closure means that on getting a input of epsilon, which state you can reach. Okay, so where the epsilon closure is nothing, just on getting an input of epsilon, on which state you can reach. Okay, so if I say that epsilon closure of A, epsilon closure of A, I think it is not going anywhere. So in the set, A will always be included. Keep that mind that closure of something is something itself. Okay, so if I am talking about epsilon closure of A is always included in the closure set. If I say B closure, B will always be included in the closure set. C closure, C will always be included in the closure set. Keep that in mind. Okay, so if I say that epsilon closure, if I just write it like that, it can be denoted by this epsilon closure. You can write it like this, or epsilon star is also called a epsilon closure. Okay, so epsilon closure of E here. So from E you can reach to again the first step is to add E itself. E will be always be a part of the closure property. After that from E you can reach to B, and you can reach to C. So that will be the epsilon closure of E here. Okay. So on getting a input of epsilon, the states you can reach is automatically included in the closure property. Also, that if I say that this, I have to calculate this on this, that this state is already included in that. Okay, so keep that in mind. This is one of the main steps. Okay, so if I just show you that what is the closure of states here. So suppose this is the algorithm here. So it is saying that closure or epsilon closure of A here. Okay, so I'm talking about epsilon closure of A. So epsilon closure from A here, if you see that A will always in the set, and on getting an input of epsilon, it is going nowhere. So epsilon closure of A is simply A. But if you see epsilon closure of E, okay, so there is one more closure in the previous example that I have not added. So again, I will show you that epsilon closure of E here. Firstly, the set element will always be added. So E is added in this. After that, from E, you can reach to B. Okay. So from B, you can reach to D also. And from E, you can reach to C also. Okay. So these are 1, 2, 3, 4. 4 state will be the closure of E. Okay. So keep that in mind. In the same way, if I calculate the epsilon closure of B. So, okay, epsilon closure of B. So B will already be in the set. Okay. So after that, you can get to D after getting an input of epsilon. After that, no output is no, you are reaching from no state from B. Okay, so I'm getting a input of epsilon. So only one epsilon is defined here, another is one. Okay, so only so that D will be included. So this is the epsilon closure of B here. So I think most of you will get that what I'm saying here. So this is the foundation step to convert any Epsilon-NFA to a simple NFA. So I just show you that this is the algorithm here, and you know the algorithm is quite simple, and it will seem very difficult, but it is quite simple. Just let me do some question, and you can again look at the algorithm. It is very simple. So just copy and paste this question. Okay, so carefully look at this question. Okay, we will do 2 3 questions so to get a better understanding of this. Just decrease. Okay. So to convert any epsilon NFA to a simple NFA, first of all you need to know that how to calculate epsilon closure. So I think you got that step. If you do not, again look at what I'm doing. Okay, so the simple algorithm that I follow, that it is written also there, it is that epsilon, you have to take a epsilon closure first. After that you have to give input something, it can be 0 or 1. In this case it is 0 or 1. After that you have to again calculate epsilon closure. Okay, so these are this is exactly the algorithm. If you follow these 3 steps, you can easily convert any epsilon NFA to a simple NFA. Okay, so I just follow it. I know that there are 3 states. Okay, so 1, 2, 3. So I just write it as A, B, and C here. On getting, now I just write the NFA table directly. Okay, so how can I do that? First is 0, or this is 1. I will directly write the NFA table. Okay. So these 3 steps, keep that in mind. So firstly on A, now I'm on A, I have to fill this part. On A, getting a input of 0. Okay. So the first step is take a closure of A. So the closure of A is, always keep that in mind. A should be included first. After that, from A you can reach to B or to C. Okay, so these are your epsilon closure of A here. So after that, what is the next step is the input. So what input are we following? It is 0. Okay, so 0, 0, and 0. So A on getting an input of 0 is staying at A. B on getting an input of 0 is going nowhere. So I just write epsilon here. This is dead configuration if you remember. And C on getting an input of 0 is staying at C. Okay, so after that the third step is your epsilon closure again. So start with the epsilon closure again. So the epsilon closure of A is A itself, after that B and C. The epsilon closure of this step is nothing, so it is stopped here. The epsilon closure of C is C itself, after that it is not getting any epsilon input. So that set here becomes A, comma B, comma C, comma C. So as this is set, I cannot include 2 C's. So there will be only 1 C. So I think you got most of the thing. Again, we will follow the same approach again. On A, so you have to first calculate epsilon closure. Epsilon closure of A is A itself, after that B and C. After that the input of 1, 1, and 1. A on getting an input of 1, it is going nowhere, so this is a dead configuration. B on getting an input of 1, it is staying at B. C on getting an input of 1, it is staying at C. Okay, so after that again take a epsilon closure. So epsilon closure of dead configuration is nothing, so stop there. Epsilon closure of B is B itself, it is followed by after C. So on B, if you give epsilon input, you will go towards the C state here. Okay, so here now you will get 2 states. After that take a epsilon closure of C here. So epsilon closure is C, it's C itself, after that it is going nowhere. Okay, so here the answer here will be B, comma C. I think you get the point. Okay, so these 3 steps we have to follow continuously. Okay, so if I again go for the B here, B, first you have to take a closure. You have taken a closure. Closure of B is B itself and C. On getting an input of 0, now we are talking about 0, on getting an input of 0. So B on getting an input of 0 is going nowhere, so this is a dead configuration. C on getting an input of 0 is staying at C. After that, take a closure. Closure of this dead state is nothing, dead configuration. Closure of C is C itself. After that, no epsilon is inputted here. So here the state is your C state. After that, from B, okay, so you can look at it from B. Again, the closure will be B and C. Again, on getting an input of 1 from B, it is staying at B. On C, it is staying at C. So epsilon closure, again take the epsilon closure of B, which is B and C, and take the epsilon closure of C, it is C itself, and there is no input of epsilon here. So the answer here will be B comma C. Okay. So now on C, again for go for C here. So the same steps has to be followed. So take the epsilon closure of C. Okay. So it will be C. After that, I think there is no input of epsilon on C. So I think it will be only C. After that, the input is 0. So on 0, it is staying at C. So after that, take a epsilon closure of C, which is C itself. So here, the input is C only. Okay. So in the same way, go for the same steps. Epsilon closure of C is C. After that, the input of 1, it is staying at C. So take the epsilon closure of C, which is C itself. Okay. So your transition table looks like this. If you again, do not worry about that. That is the table of NFA. So at NFA, you can by getting an input of 0, you can go towards multiple states. Okay, so you remember the property. Okay, so if I draw the transition diagram of this, it will look like this. Okay, so it will look like A, and this is your final state, and this is the initial state. So this is again the one and the same. Here is the initial state is A, final state is C. Okay, so I'm following the same notation. Okay, so the initial state here is A on getting an input of 0, it is staying at A, it is going towards B, it is going towards C also. Okay, so C, I just write it like this. So it will be your C state. Okay, on after that, on getting an input of 1, it is going towards B and C. So here will be 1 B, and here will be 1 C. Okay, on B, on getting an input of 0, it is going towards C. On getting an input of 0, it is going towards C. Okay, on getting an input of 1, it is staying at B, and it is also going towards C. Okay, now C, it's just a self loop. Okay, so 0 and 1 is a self. So this becomes your from epsilon NFA, it is converted into a NFA. Okay, so this portion is your NFA. Okay, so in the same way, if you find go in the slide, there is also another question for you to try. Okay, so in this one, in this, I think the solution of this is given in the next slide. This is the same thing that I have drawn. Yeah, that is the same thing. And this is a question too, also you should try it yourself. But in the solution of it, keep that in mind. This is not, there is a little bit of mistake in this. First, just tell you what is the mistake. First, if you again see it, that there can be only one initial state. So it is taking us to two initial state. So from starting here, the initial state is Q naught. Okay, so this is not an initial state. Keep that in mind. In the same way, this is not a final state. Okay, so in the previous one, the final state is Q2, so the final state will be Q2 here as well. Okay, so this is for you to try at home, but I will give you another question to get a better understanding of what we have done. So this question you try it yourself. I will tell you the solution in just 5 or 4 minutes. You should try yourself. So this is the question that I want to do. I think that is similar to the one we have done. Okay, so just little bit, I just introduce a little bit of notation here. This is epsilon also, and this is your final state D. And again, I include another state C here. Okay, so this will be your state C, and from this and this, I just do the uh, transition of 0 and 1, and goes like this. Okay, yeah, I think it is correct. Okay. So just try to solve this and convert this into NFA. I will tell you the solution. We will solve again, but you should try it yourself. Okay. So I will tell you the solution after 5 minutes. This second question, try it yourself.
Sir,
Yes, yes.
sir, simpler NFA means NFA without epsilon, right?
Yes, yes. Simpler NFA means this is your epsilon NFA, and you have to convert it into a NFA. And NFA does not contain any epsilon move. So keep that in mind.
So only if NFA does not contain epsilon, then can be called as simpler NFA. No other conditions, right?
Yes, yes. No other condition.
Yes. Sir.
Okay, so if you tried it, I think it's a bit of a lengthy question because of the introduction of the C. It will take like 4 states. Okay, so it will take a little bit of time. Okay, so it can also be possible if you are doing it that on any number, on any state, there will be there will be no transition. Okay, so the epsilon move is also possible. Keep that in mind. That configuration is also possible. Okay, so if I just tell you again, follow the same procedure. So this is the second question that I'm solving to get a better understanding of it. I think you got it, but the more you try, the more you will get this. Okay, so this is 0 and this is 1. I'm directly converting into an NFA. Okay, so go for the same thing, that epsilon star followed by the input followed by epsilon star again. Okay, so if I go with this a on getting epsilon star here, what is the epsilon star? Meaning epsilon closure of a is a itself. After that it can reach to b. After that it can reach to d also. Okay, so I think you cannot reach c on getting an input as epsilon. So these will three will be your this, and after that you have to input 0 here. So if you input 0 0 0, so saying 0, it means it is all the inputting 0 on all the three. On any the answer is on getting input of 0 at a, it is a. On b it is, I think, nothing. Yeah, it is c. C. On d it is staying at d. Okay, so after that you have to take epsilon closure. So epsilon closure of a is absolutely, you have again done it. So it is abd. In the first step you already done it. So epsilon closure of c is absolutely nothing, so it is epsilon, and d is d itself. So this will be again the c is already included in that. Uh, after that you can there is no epsilon here, so it will be c, and the epsilon closure of d is d. After that there is no transition of epsilon on d here. So the set becomes a followed by comma b, comma c, and comma d. Okay, so the first will be this. After that, again you just have to change this part. I just change this part because the everything will be the same. I have to take the epsilon closure of a. You have to input 1 here. Okay, so for 1, so it will be on a 1 is not defined, so epsilon. On b 1 is going towards 1. No, 1 is not defined on B also. So if you see, it is from C, it is going towards B, but B is not going towards anybody. Okay. So on D here, it will be on getting an input of 1, it's staying at D. Okay. So the epsilon closure of D is D itself. I think only this. Okay. So this is your first starting one. After that, if you follow B, the epsilon closure of B is B as well as D. Okay, so on getting an input of 0, B can go towards C. On getting an input of 0, D stays at D. Or epsilon closure of C is C itself, and there is no input of epsilon. D, epsilon closure of D itself, and there is no input of epsilon. So the set here is C followed by a D. In the same way, for this I just change this part. For getting an input of 1 here, so what is 1? On B getting input of 1, it is absolutely going nowhere. On D it is getting an input of 1, it is staying at D. Okay, so the epsilon closure of this phi is nothing. Epsilon closure of D is D itself and nothing new. Okay, so it will be like this. After that, check for C. So again for C, check the epsilon closure. I think it's C and nothing more. After that, on getting input of 0, it is going towards nowhere. So epsilon closure of this phi is absolutely nothing. So this just remains as a dead configuration. Okay, so it can be possible. So don't worry about that part also. Okay, well, in the same way, epsilon closure of this is C. and on input 1 it is going towards B, and on epsilon closure of B is B itself, and it can also be D. From B, D can be reached. Okay, so it will be B comma D. In the same way, I think only one is the remaining. Okay, so let me just remove this part. Okay, so take the epsilon closure. I think it is fairly simple. Epsilon closure of D is D on getting an input of 0. It is staying at D. The epsilon closure of this is D itself. Okay, so this is D. In the same way, D epsilon closure of D is D on getting an input of 1. It is staying at D, and epsilon closure of D is D. Okay, so this is your uh, NFA. Okay, so if you draw it in the first state, there are 4 possible combination of state. So it will be one and the same thing. You can draw it yourself, or again, if you see that the language that is accepted before is also accepted in this equivalent NFA also. If you see that what is happening, any number of zeros followed by any number of ones, after that the language looks like this: any number of zero followed by any number of ones. After that, 0 and 1 can come any number of times. Okay, so it just looks a little bit of different language, but it will, the final state here is C here. So if you clearly see uh, any any number of 0 in the starting, followed by a 1 and a 0, 1 or a 0. After that, okay, so this is an NFA. Okay, so 0, if you want to conclude this part, that 0 star 1 star, and after that any number of 0 and 1 can come. Okay, so first this is a 0, so 0 star will be that part. If you clearly look at this, 0 star followed by is any number of zeros, after that any number of ones, as well as 0 and 1s can come. In the same way, this part can be a different part. But if you just put the language that is accepted before, if you see that like 0 0 0 followed by 1 and 0 is in the language. If you check in this is also be a part of this language. Okay, so what is this? 0 0 0 1 0. So 0 0 0 and 1, so it will reach to B on 1, and 0 it will reach to C. Again you can do this 0 0 0 and 1 and 0. Okay, so all the language that is accepted before again is the same language that will be accepted in this also. So it will look a little bit of complex, that this thing is not equivalent to this, but if you just do 1 or 3 or 4 number of strings to give this automata some number of strings, you will get this. Okay, so I think that is enough for today. Okay,
Excuse me, sir.
yes, yes.
Sir, will A be a final state?
Will A be a final state? Because in this there is no the final state is C here, so that is why the final state here will be C always.
Sir, but in the epsilon NFA, we can reach C through an empty string.
Yeah, but the language accepted by this, it will be, you can say that 0 star is accepted by this. Okay, so from A you can reach C, so it means that any number of zeros can get accepted. Yeah.
No, sir, but in the initial epsilon NFA, I can reach C without giving any input.
Yeah, this is absolutely possible, but we have converted this epsilon NFA into a NFA. So the epsilon move will not be possible in NFA. So that is why I'm saying that the language accepted by the epsilon NFA will be equal to the equivalent NFA that we have converted. Okay, so if you see that, if you're saying that that it can reach to the final state, that is C, so it means that it can accept any number of zeros. From 0 it can from A it can generate any number of zeros, from B it can generate any number of ones, then it can reach on C. So it is same as saying that any number of zeros can also be generated by this. After that, in the final state, any number of zeros and ones can be generated by this also. Okay. So you have to check the language that both of these are accepting the same language. So that is the equivalence here.
Sir, but in the epsilon NFA, I can reach C without any input from A.
So in NFA it is not possible. Now how can you reach from A to C without getting any input? So this is not possible. I have
Sir,
to
but
place an epsilon move here. So epsilon move, if I place an epsilon move in NFA, that will become your epsilon NFA. Is your question a bit different?
no, sir, I'm asking that in the epsilon NFA, I can reach from the starting state to the final state without giving any input. But I can't do the same in this NFA. And to do that, I have to make A the final state.
Okay, so your argument is that you can make this A as a final state. Okay, so you want to say this to
Yes, sir.
make that possible. Okay. So if I just do this, it is not affecting anything if I just see this, but this is not the algorithm that we have to follow. Your argument is right that that this should be equivalent, but I am only talking about in a way of a language. Okay, so if I just find any string that is possible here, not here, I think I cannot find it. A, any number of A's, any number of zeros, and you can reach to the final state. Okay. You can make this a final state, but in the algorithm, this is not the way. Yeah, you are saying it right, but if I do a final state here, it is absolutely not affecting the number of the languages that is accepted by our equivalent NFA, but the procedure does not say, because in this particular question that you are getting away with making A a final state, but in all the question you cannot generalize this concept. Okay.
Okay, sir.
Just
Thank
keep
you.
that in mind. Just have to check the languages that is accepted by Epsilon NFA has to be exactly accepted by your
Okay,
equivalent.
sir. Okay, sir. Thank you.
Okay, so we will continue
Sir,
in the next. Yes, yes.
for the second example, can you draw the diagram, NFA diagram? Simple NFA.
Okay.
Second example.
I think it will be a bit difficult, and I think the transitions will be very high. So I just draw it. Okay. So from A, you got to A, you can go to B, and what is your final state in this? Just let me look at this.
So,
Yes, yes.
sir, why didn't we consider C for the silent closure of A?
Why did not we consider C?
In the silent closure of A, we had A, B, and D.
Uh,
Yes, sir, this one.
this one?
So, on the other side, A epsilon.
Yeah.
Yeah, so we have A, B, and D, but
Mm-hmm.
we haven't considered C in this. Now, the
So,
closure only consists of those like states which we can reach by having epsilon.
yeah,
So
and
throughout all the
and
states,
the
the
state
should
itself,
be epsilon.
and the state itself.
Yeah, the state itself and the input for every other state should be epsilon itself.
Yeah.
All right, sir. Okay.
So from B here, I think there is no kind of epsilon move here. That is why I've written this.
So, I got a little confused because in the last example,
Hmm.
I guess you wrote it incorrectly somewhere. That E epsilon for the last graph you drew was A, B, C, and D. and there was no epsilon connection between E and C.
Okay.
Right, sir.
Okay. I think the question asked by the previous student is the right question. Okay, A has to be a final state here because I just forget one thing that that this C is the final state and this state this uh, just let me get to it. Okay, just wait a minute. I just let me check this. I think I got something mixed here. If D is the final state in this one, okay. Okay. So for final state, just hold it. I think there is something a little bit of mistake by me. So for a final state, just hold it. Okay. So I will tell you in the next lecture. There is something that I did wrong. Okay. Okay. So for that, if I just draw it in this also, there is a concept of the final state. Okay. So just wait and hold for this lecture. I will tell you in the next one that there is something I'm missing in this. Okay. Okay. So I will explain this question again in the next lecture. There is some mistake of a final state. Okay. So, okay, you can go towards the next lecture and thank you for listening.
Thank you, sir.